Hello everyone. In this lesson, we are going to be looking at some basic definitions that will help us understand some concepts in this basic mechanics course easily. So I have the first term here, which is space. Space represents the entire expanse where a point or an object with a negligible size can potentially exist. Okay. So it represents the entire expanse where a point or an object with a negligible size can potentially exist. The second term is particle. A particle is defined as a very small amount of matter which may be assumed to occupy a single point in space. Okay, so that's the definition of a particle. So we assume that particles occupy a single point in space because particles are considered to be infinitesimally small in size. So for this reason, the volume they occupy in space is considered to be insignificant. Okay, so we see that they occupy a single point in space. The reason why we represent bodies as particles in this course is that representing bodies as particles makes some analysis and calculations very easy to deal with. That's the reason why we sometimes represent some bodies as particles, because with some problems the size or the shape of the bodies do not matter. Okay, so for things to be easy for us, we will just have to represent the bodies as what? Particles. Let's look at the next definition. Rigid bodies. A rigid body is a combination of a large number of particles occupying fixed positions with respect to each other. Rigid bodies are not deformable. Okay, so the reason why rigid bodies are not deformable is that the definition is telling us that the particles are occupying fixed positions, okay, with respect to what each other. So what is happening is that because the particles have fixed positions, no matter the external force that will be applied to these rigid bodies, the position of the particles are still going to be the same. Okay, their positions will not change. So for this reason, the body is not going to change in form or shape. Okay, which means that the body is not going to what? Deform. That is the reason why we say that rigid bodies are not deformable. Should it be that the position of the particles change after an external force has been applied, then you are going to see that the body is what? Deformable. Okay, but this is an ideal case because all bodies are deformable. Okay, they might be difficult to deform, but I think all bodies are deformable, so this is actually an ideal case. Okay, so let's look at the next definitions. Time. Time refers to the interval between two events or the duration of an event. Inertia. This is the property of a body that causes it to resist motion. Okay, so it is a property of a body that makes it resistant to motion. Mass is a measure of inertia, which means that it is a measure of a body's resistance to motion. The bigger the mass of an object, the bigger the inertia. Force. A force represents the action of one body on another. Okay, so in Newtonian mechanics, space, time, and mass are considered absolute and independent of each other, while the concept of force is intimately linked to this concept. Okay, so in Newtonian mechanics, space, time, and mass are considered to be absolute, which means that they don't depend on any external factors, and then they are also independent of what each other. But the concept of force is dependent on space, time, and what? Mass. Okay, so that's one thing you have to know about Newtonian mechanics. When we say Newtonian mechanics, it is also called the classical mechanics, okay, which refers to the branch of physics that deals with the motion of macroscopic objects under the influence of what? Forces. It is named after Sir Isaac Newton. So you can read more about the Newtonian mechanics, okay, how it came about, so that you know a lot of not so that you know more about this course, okay, how it came about, and then other relevant information. Okay, so the study of this basic mechanics course rests on some fundamental principles that are based on experimental evidence. They are: one, the parallelogram law for the addition of forces; two, the principle of transmissibility; three, Newton's three fundamental laws; and four, Newton's law of what? Gravitation. So these are the fundamental principles that this course is based on. So you are going to take a close look at each of these principles, okay, in my subsequent videos. So please make sure you subscribe to the channel and turn on your notification bell so that you can receive updates anytime videos are posted. Thank you very much for watching this video.